Hello and welcome to SDA Tech Forum. So in this SDA series of video, I am presenting you another SDA technology pillar, and we will be discussing LISP as a protocol, not LISP deep dive as in RFC, but how LISP is used as a control plane within software defined access. So I'm keeping it very relevant to SDA. Okay. So let's get started. Technology agenda is pretty clear. We will understand what is LISP, why LISP, what are the different terminology of LISP with respect to SDA, and then I'll show you a demo that how our client and identity and location comes into picture when a client try to communicate with another client within a fabric domain. So LISP, or locator ID separation protocol, is used as a control plane in SDA for overlay connectivity. So SDA LISP is your control plane for overlay, and the fabric communication happen in overlay, right? Underlay is very simple, and we assume that underlay is already configured and it is working. That means you do have RLOC to RLOC reachability, and if you don't understand this terminology, just hold on, I'll explain that. LISP proposes the separation of location and identity into two separate namespaces: identity namespace and location namespace. So in our traditional routing switching environment, your IP is your identity, and it also roughly tells you like how where you are. So it give you a sense of location also, because when we do IP address planning, we try to reserve the IP address based on some geography, right? But LISP is a new thought process where it decouple identity and location. So network hosts are referred as endpoints and or identity namespace, and are assigned addresses in the identity namespace. It is also called endpoint identifier, EIDs. Okay, so this is one of the terminology. And if we have to take an analogy, then these are analogous to name of the person. So if you are familiar with post office system or a mailing system, it represent EID represent the name of the person who is the recipient. Okay, the network device to which host attached are assigned addresses in the location namespace. So network device where the who is actually catering the endpoints, they are provided addresses from location namespace. In LISP we call it routing locators or RLOCs. So that's the second very important terminology after EID and RLOC. And RLOC denotes location namespace, and these are analogous to your street address if you look at the mailing system analogy, right? So EID is your name of the person, where RLOC is street address. When you combine them together, packet can reach to the right designated host, right? So what is the benefit of decoupling location and identity? It enables functionality such as host mobility, large-scale segmentation, traffic engineering, location-aware use cases, etc. So there are multiple use cases, right? The more it provides for SDA, the host mobility is the key. Also with segmentation, but host mobility is the key here within SDA. That's why we choose to use LISP. Now, with respect to SDA, this is my fabric domain, right? Generally, you have your fabric edge routers and then fabric border routers, and you may have a fusion router for external connectivity, and then you have your DNAC, ICE, and IPAM shared services, right? So we are very focused here in this part, fabric part, and you can see that I have fabric edge routers and fabric border router, and according to LISP they are holding different roles, right? So my border is a database, and we call it control plane also, CP, and my fabric edge they are ITRs. So what is ITR? I'll explain you later. But here you can see on very high level, LISP is used as a control plane. The data plane, of course, is a VXLAN encapsulation. We'll talk about that in a later video. But what is going on here is fabric edge responsible for local endpoint registration to MSMR, and we'll discuss MSMR in upcoming sections, and maintain a local map cache. So it'll learn about the locally connected endpoint and register it with the control plane, which is hosted with the border here in this scenario. MSMR or control plane maintains central LISP database and have all remote endpoints and RLOC info. So it's like a central database. Traffic is VLAN encapsulated towards RLOC, and SGT. SGT is a concept for segmentation. Anycast gateway is available for each VLAN with option 82. So if you are not familiar with Anycast gateway and option 42, watch my other video where we have discussed how DHCP works with Fabric. But in typical software defined access or programmable Fabric, the layer 3 resides at Fabric edge, where you have same IP address SVI available on all Fabric switches. Okay, so now let's talk about LISP terminology, right? So there are a couple of things very important to understand in LISP. The tunnel routers, and when I say routers, it may be a layer 3 switch also. And in Cisco SDA environment, we are actually using Cat9K or 3850 switches, layer 3 switches. So take it with a pinch of salt, like router and switch interchangeably can be used here. So tunnel routers are the network devices at the edge of LISP. These routers perform the encapsulation and decapsulation of EID traffic. See, EID is your end host traffic into RLOC address tunnels. These routers are also responsible for populating and querying the mapping database. So your tunnel router actually talk to MSMR or control plane database, and they register, they ask for the query if they don't have the information based on direction. It could be ingress or egress, or even proxy if you're talking to non-LISP domain. So it may be a case that you have a LISP domain, but you want to talk to outside world where there is no LISP. So you can do that via proxy tunnel router. Usually, most tunnel routers are deployed as both ITR and ETR, because they will serve as egress and ingress for both kind of traffic. Ingress tunnel router, it is the entry point of traffic from LISP site into the overlay. So it is the entry point. Your traffic from endpoint is entering into the overlay. ITR is responsible for querying the mapping database to obtain locator mapping for EID for which they receive traffic. So ITR sends query to mapping database or control plane when they receive traffic, if that information is not in their map cache. And what is map cache, I'll explain you later. ITR uses, sorry for the typo, ITR uses LISP message known as map request for the same. So to query control plane, it uses map request. ITR also cache this information in map cache. So once you query control plane and you have this information, you cache it. Like ITR are responsible for encapsulating traffic to a destination location. It receive IP packet from site end system on one side and send LISP encapsulated packet, because it is accepting endpoint traffic, which is a IP traffic, and then it encapsulate and send it to the ETR. Egress tunnel router. ETR are exit point of the traffic from the LISP overlay network. So think of it like now you are leaving LISP overlay and going towards the endpoint, just opposite to ITR. ETR are responsible for de-encapsulating the traffic they receive. ETR are authoritative for the set of EIDs locally available for their site. The EID to RLOC mapping are defined at ETR, and ETR uses LISP map register message to register as authoritative. It accepts IP packet where the destination address is in outer IP header is one of its own RLOC. So it actually get IP packet, obviously VXLAN encapsulated packet, where the outer header is set to its own RLOC. That means that traffic is destined to its own RLOC, and then it look at the packet and send it to the end host. XTR is referred to the device which function as both ITR and ETR, and typically all the tunnel routers, they work as XTR. Proxy XTR, again XTR, that means irrespective of direction, ITR or ETR. But as we discussed earlier, proxy is for internet working between LISP and non-LISP sites. Now let's talk about the second important concept after tunnel is your control plane, or in LISP terminology we call it mapping database system, but in SDA we call it control plane or CP nodes. CP nodes map system that manages the endpoint to gateway relationship. So it has both the information, EID space information and RLOC information, and how they are related. So that mapping is available at control plane. Its function is to maintain the database of mapping and service those query for those mapping. So it maintain that database, and also it services the queries coming from ETR or ITR. So there are two distinct roles, map server and map resolver. Most of the time they are hosted in the same node. That's why our control plane in SDA, it serves as MSMR. But in distributed LISP environment, you can have different nodes catering a different role. But in SDA environment, our control plane has both the roles. The MS map server receives all EID registration and install the registered EID to RLOC mapping in the database. ETR is responsible for registering its local EID to RLOC with MS. So whenever a new endpoint comes up, ETR actually send registration request to map server, and map server have registered that node and acknowledge and maintain it in database. Okay, we'll see how MSMR works. So MSMR in action, here you can see I have two client hosts and Fabric Edge 1, Fabric Edge 2, they are ITR, ETR, and I have the control plane here which is acting as MSMR. So two important processes happen in LISP. Host registration, first is host registration. So client 1 comes up, it sends ARP or DHCP or maybe a data packet, right, to the other side. FE, Fabric Edge 1, saves the host info in the local database. So it learn about the client 1, save this info in local database, and at the same time it send the registration message to control plane map, which is map server. Map server receives the registration message, save the host and save it in host tracking database. We called it LISP HTDB, and send the acknowledgement. So that's how control plane populate the EID to RLOC information, and our Fabric Edge is responsible to do that, to register their local endpoint. Then what happened? Host resolution. Now imagine client A want to establish a communication with client 2. So it has no local map entry for client 2. So what Fabric Edge does, it sends the map request to control plane or the map resolver in this case. So basically Fabric Edge says that, okay, I want to reach to this client, I don't have the information, let me query map control plane or map resolver. So map resolver forward the original map request to gateway, other gateway, and then that last registered the EID subnet. So my CP know that who has this address space, and he send that query, he direct that query coming from FE1 to FE2. FE2 then sends to FE1 a map reply. So FE2 send a map reply back to FE1, and FE1 install this mapping information in local cache. So this is the flow, but mind it, in some implementation control plane itself can entertain the map reply, okay, instead of directing the original map request to the ETR. So this is the two important process, like it's like a routing lookup, or how the routing happens. So this is how LISP gets their mapping database populated, and host resolution is actually a process of like database lookup. Okay, now let's discuss the demo. So in this demo, we are going to walk through the different outputs, and I have this setup up and running, but it's much easier to look at the output on the slides itself rather than router. But let me show you my setup. So in this setup, I have a GBR router or switch, which is working as border and control, and then I have edge 1 and edge 2, which are obviously our fabric edge router. I'm quickly going to show their IP addresses here. So first thing, what you are interested in, okay, because this is a little chatty, I'm on console, and that's why I plan to show you everything on, because we can look at the important part of so let me first show you loopback addresses, and you can see it's 192.168.60.51, and show LISP session. So it has a LISP session with a couple of other routers. The switches we are interested in is 192.168.13.65 and 13.69, because these are my fabric edge 1 and fabric edge 2. Okay, let me go to fabric edge loopback 0, and you can see that IP address is 192.168.13.69, and it has a session with 51, which is nothing but my GBR router or a border router. Okay, and you can see that it uses a port number, typical port number 4342, which is for LISP console session. It's a registered port for LISP implementation. And the same thing I'm going to show you for edge 1. Sorry, I'm thinking something else. And you can see the IP address is 192.168.13.65, and it has a LISP session with border 60.51 on port 4342. Yeah, and also both my edge switches, they have a fabric connected, so a host connected, and I'm going to show you okay. So authentication session interface 10.102 details, and you can see that I have a host connected here, and the host has been silent for some time. That's why it's not showing the IP address. And same thing, I have another host connected on my another fabric switch, and DCA4 part of VLAN 1025. Okay, so both the fabric edge, they have the host connected. Now let's go back and look at the output from the document. Okay, so the first bullet I shown you, show LISP session on all involved devices like border and edge. On edge we have LISP session with border. On edge 1 and edge 2 we have Lisp session with border, and on border we have Lisp session with both the edges. Then what you want to do, you want to log into this control plane or the border node and verify if the map server or map resolver functionality is being enabled. So what you can do show IP Lisp include map, and you can see that MSMR is both enabled, and it also says that ITR map resolver and map server is 192.168.60.51, which is nothing but GBR himself, right? GBR IP address, you can see 60.51. So border or control plane is my MSMR, and it is pointing to itself. Okay, next what you want to do is you want to verify on fabric edge. I am using the same command, show IP Lisp include map, and here you can see it's disabled. MSMR is disabled obviously because my fabric edges, they are not control plane, but they know who to send the query and registration. So the IP address is set to control plane IP address. MSMR functions are disabled, but ITR, MS, ETR, MS pointing to CP node. Okay, so far so good. So control plane has MSMR enabled, and it know that it has to entertain map register and map resolver, and my fabric edge has no MSMR but functionality enabled, but it know who to send out host registration and host resolution message. And then what we are going to do, we are going to dig deep and see verify Lisp instance ID to VRF mapping. So, and then verify which prefixes under which VRF are allowed to be registered under the site. So first thing is, let's see Lisp to VRF mapping. So I'm doing show Lisp VRF, and this is my VRF campus VN, and it is tied to Lisp instance ID 4099. So see how the traditional networking and the Lisp concepts are getting integrated. So Lisp understand instance ID, which in turn is binded to our VRF. Within VRF we have the VLAN, so I'm doing show VRF campus VN, and I have all these VLANs, they are part of this VRF. Then let's see show run section site UCI. Output is trimmed, but look at the site, and the site is site UCI, and under that, and this is on control plane, I have EID records, right? I have EID records with Lisp instance ID and the EID space or identity space. So what it is saying is for Lisp instance ID 4099, which is VRF campus VN 24/24 and above, that means more specific 25 to 32 will be accepted if map registration come with the password. Okay, so basically Lisp control plane knows that if any host which is a part of the 172.1691.0/24 or specific, if any host registration messages comes, it is going to accept that and populate that in database. Okay, let's verify the same thing on fabric edge. On fabric edge, you can see that there is a dynamic mapping available for the same subnet with the locator set of itself. So it is saying that I am responsible for this subnet with and it is reachable via locator set. This is not very intuitive, but it is actually pointing to itself. Okay, above configuration suggests that edge router will register host within the defined /24 subnet once they are onboarded, and show Lisp VRF in step 4. We know that that is 4099. So we have seen the Lisp to instance ID mapping earlier, and also VRF campus, we know what are the VLANs. Now let's check the VLANs. Okay, so let's pick one of the VLAN 1025, which is part of campus VN, VRF campus VN, which in turn is Lisp instance ID 4099. So what is configured here is a MAC address, a static MAC address It's a part of VRF campus VN and IP address, and then you have Lisp mobility configured. So each prefix is bound to a Lisp mobility map. Let's first discuss about this, which that is applied to the respective SVI interface that act as layer 3 Anycast gateway. So this is our Anycast gateway. That means you have the same information available on all the fabric edges where you have the host in this subnet. Okay, that's how the Anycast gateway works, and they have identical MAC and IP addresses. So that's why we are using a static MAC, so that we can repeat this configuration on other switches. SDA host mobility introduces the concept of Anycast IP, where all fabric edge routers that carry the same VRF share the same config to provide total transparent mobility. If an end user decides to move, he does not need to re-ARP nor alter his gateway. Everything stays the same. Once the user onboard the new edge will trigger the map register. So basically, that is the advantage, right? We initially talked that why we are decoupling identity to location, because when the host moves, that means the identity move. When the host moves, it keeps its identity. Only thing it changes is the location or RLOC identifier. Okay, so now let's understand the different databases. So local registration are stored in Lisp database. So any local and locally connected endpoints, they are stored in Lisp database. So as I mentioned earlier that I have on Fabric Edge, we have a host connected, and you can see that we have a host with a MAC address 2272, has an IP address of 176.16.91.21. So this is my locally connected host. I'm doing .1x based authentication, and it has received an IP address of 21. So the host got the IP address. Now the Fabric Edge is going to register this to the map server, and at the same time keep it in their local database. So let's see. Let's look at the database for this endpoint. So the command is show IP Lisp instance ID. I know this VLAN is mapped to what VRF. This VLAN mapped to what VRF, and that VRF is associated with what instance ID. So we do have that knowledge. That's why I'm saying show IP Lisp instance ID 4099. Database, that means show me the local database with respect to this endpoint. And what you would like to see is I do have a dynamic EID for this prefix, and this is my locator 192.168.30.65, and state is site self reachable. And since you can see edge 1, this host is connected on edge 1, and edge 1 has a loopback of 13.65. That means it says that, and state is site self reachable. That means this endpoint is locally connected and it is reachable via my own RLOC. So that's where we are looking at database. Okay. What about remote endpoints? What if the host is not connected to ourselves, right? So while remote endpoints, which are learned on demand, okay, so it's not that we keep all the endpoint information. It's learn on demand. If you have a need to communicate to another client, then only that information is learned. Okay, and it is stored in map cache. So Fabric Edge query MSMR and get the reply back, and it's stored in cache table. Okay, to see if a remote Fabric Edge knows about client 2, we need to query the map cache instead, right? So when you want to reach a remote endpoint, that time you will not look into your database, but you will look at map cache. Okay, so here are the two scenarios. Since we are saying that Lisp is demand based, that means when a client 1 didn't contacted client 2, okay, then what happened? So I'm on edge 2, and we are looking for an endpoint 91.21. Where 91.21 is connected? 91.21 is connected on edge 1. So edge 1 has 91.21 connected, but we are looking from edge 2 perspective. Okay, so when edge 2 never contacted this client, what happened then? So what we are doing, show IP Lisp instance ID 4099 map cache. Okay, look in map cache for this particular endpoint, and you can see I do have this information as dynamic EID, but sources are none. Okay, so basically I never contacted it, so I never got this information particular to the end host. So what I did second is I initiated a ping from client 2 to client 1, and then recheck the command again. That time what happened, we are issuing the same command, but since we have ran a ping, that means my fabric edge has actually sent a map query, resolver query to the control plane, and control plane has replied. So now I do have that information and I have stored it in my map cache. So see how the output changes here. So now I'm saying for this endpoint 91.21, uptime is only 16 seconds, but it expire. So basically we cache it for 24 hours. Okay, and how we got this information? Via map reply. Source is map reply, state, all those other information. How it is reachable? It is reachable via 192.168.13.65, which is Fabric 1's loopback IP address or Lisp locator IP address. Okay, and edge, this is our edge 2, which is 13.69. Excuse me. So that's how Lisp do host resolution, and then host registration, resolution, keep it in local database, and for remote endpoint it keep it in a map cache. That's from the fabric edge perspective. On control plane, it has MSMR functionality. That means it register host and it reply to any map queries. So I hope you find this useful and you feeling comfortable with Lisp concept. Most of the configuration what I have shown you here, they are dynamic. That means DNAC is responsible for pushing that configuration based on the intent you have expressed via UI. So don't worry about the complex configuration. All you have to do is, or we have to do is understand the concept, how Lisp works, so that when we actually start building SDA via UI, you know all this secret sauce well before. And that's why I'm doing this video series of SDA technology pillar, so that you have all the technology background, and when you start building your SDA via using DNAC UI, you don't feel that this is like something very complex or something what you don't understand. So I hope you like the video. Thank you for watching this, and if you have any questions, feel free to put in under comment section. Thank you.